All right, happy Pi Day, everyone. So in addition to going over the quiz, I had some fun kind of Pi Day puzzles planned for you guys. So this video, really, it's all bonus. This is not part of the required curriculum that we have to teach, but I know some of you guys enjoy puzzles, and I'm going to incorporate these puzzles into the homework bonus. Okay? So for the bonus, you can either do both puzzles 1 and 2, or just do puzzle 1 and 3 and hand it in. I guess if you want, you can hand in all 3, but I'm only going to grade either 1 and 2 combined or 3 combined. So for the first puzzle, hopefully it's relatively straightforward. Imagine we have a square box, and we put a pie inside. Okay, so it's a circular pie. And actually there are lots of ways to put pies inside. I have these smaller pies where I can fit 4 of them in. 4 equal-sized pies in. Sorry, the drawing's not great. They're still circles. It's the same size box. But I also have even smaller pies. I have these pies that are so small that 16 of them fit perfectly inside my box. Okay, excuse the bad drawing. So I have all this pie. You get the idea. So the question for you is, which box that I drew contains the most pie? The most pie is a fancy way of saying the largest shaded area. And just to be clear, I'm going to just shade in the rest of these pies too. Alright, so that is question number 1, pie themed. The next puzzle is a little fun one, where imagine I have digits P, I, and E. So these are digits between 0 and 9. And I can set up numbers so that PI, if I treat it as a two-digit number and take the square root, add it to the number that E represents, I get actually the square root of the 3-digit number, PIE. So the question now is, what are PI and E? So I'll give you guys some hints to help you get started. So first of all, both PI, square root of PI, and square root of PIE are integers. In fact, they're positive integers. So actually, you're very limited into what square root of PI can be. Square root of PI, PI is a 2-digit number, so the square root of PI has to equal 0, 1, 2, up to 9 basically, because once the square root of PI equals 10, it's actually a 3-digit number. 10 squared is 100. So that should hopefully help you out quite a bit. Another hint is that what are possible values of E? Well, so we know that square root of PIE is a positive integer. And this tells us that PIE, when we treat it as a 3-digit number, is a perfect square. Okay, let's just list out a couple of perfect squares to begin with. 1, 4, 9, 16, 25, 36, 47, or 49, oops. 7 times 7 is 49, 64, and so on. And let's just look at the last digit, which corresponds to E. So the units digit of each of these numbers. My question for you is, can the units digit ever be 3 or 7? You can try listing out some more squares if you want. But some digits like 3 and 7 just never come up. So we know, for instance, that E cannot be 3, it can't be 7, it also can't be 2, and I'll let you guys figure out the rest. Okay, so I want what the digits P, I, and E represent. So puzzles 1 and 2 combined is one option for the bonus. Puzzle 3 is definitely the hardest of the 3 puzzles. It's a little Sudoku type thing, slightly more complicated. So one thing to notice first is that this grid is a 12 by 12. Okay, and we have one rule that says each row, column, and region contain the numbers 1 through 9 exactly once. So actually I'll write out more of them. I'll just write out all of the numbers. And 3 pi's. Pi, pi, pi. Okay, so as an example, if I take a look at the second row, I have 1, 2, 3 I guess still has to go in somewhere. I don't have 4 yet, and so on. And I also only have 1 pi, so I have to fill in 2 more pi's in this row. Similarly, for this column, I already have 2 pi's, so I have 1 more pi that needs to go in, but I still am missing a whole bunch of numbers too. And by region, I mean everything that shares a big, thick black border. So each region also has 12 squares. So for instance, in this rectangle that I'm highlighting right now, I should see the numbers 1 through 9 and 3 pi's. So I'm going to start by filling out some number of the entries, just so you guys get a feel for how to do this puzzle. So I'm going to first just look around and see if there are some clues that are easier to fill in. I like this region because a lot of it is already filled in, and also all 3 pi's are already filled in. So the pi's are tricky because there are 3 of them. Whereas for each number, there's only 1 copy of each. So the numbers actually tell you a lot more information. So I'm going to focus on this region over here, this 2 by 6 region. And after I just kind of look at which numbers are missing, I noticed that this square, we can actually figure out what it is. That's because the number 8 can't be in this column. So 8 cannot be anywhere here. We also know that 8's already in this row, so 8 can't be anywhere here. The only square that's left over for 8 to go in is over here. Okay? So using a lot of deductions like this, we can figure out a whole bunch of squares. So another example kind of similar is if we look at this region, we pretty much, we don't know too much about it, but we can actually figure out this square. And that's because there's already a 9 in this row, which means the missing 9 in this region can't go in the first 3 boxes. And similarly, there's a 9 in this row, which means the 9 also can't go in these 3 boxes. The only box that's left for the 9 to go in is right there. I'll do a few more steps now. Okay, so I'll show an example of a logical step that's a bit harder than the first 2. I'm going to zoom in. Oops, didn't mean to erase it. I'm going to zoom in on this row. And the reason I'm doing so is because we actually have a ton of the numbers. The only things that we're missing in this row, so let me write with a smaller pen. Missing 1, 3, and 2 pi's. Okay, so first of all, where can the pi's go? Well, no pi can go here. That's because this purple region already has all 3 pi's. So this means the pi's are somewhere here. We also know that the number 1 can't go here. So 1 also has to occur somewhere here. The only number that's allowed to go in the square at this point is 3. So whoa, we're already almost there with this whole row. Lastly, we can figure out this square. And that's because if we consider this light green region, we know that 3 can't go here from this row. We know that 3 cannot occur in this row. And we also know that we can't have 3 here. So the only spot left for the 3 is in this corner. Okay, so I gave some examples on how to work through this puzzle. So yes, the second option is to do puzzle number 3 and hand it in instead of combining 1 and 2. But be warned, 3 definitely will take more time than 1 and 2 combined. Awesome. Talk to you guys in a couple weeks.